All right, it's recording.
As everyone turns their camera off.
I mean,
Yeah,
you can if you want. It doesn't really matter.
It doesn't matter. I don't care.
Uh,
I mean, homework is the
It's
focus.
just a
today.
professor. It should just be professor. I am
Professor Edison is on the way.
All
I
right,
am
but I need to see
unemployed.
your smiling faces. Whatever. All right. So now, all right. Now we need to. Now we need to do problem 2. All right. 'Cause I can't tell if you're just like not there. You know.
Huh, I got you.
You know, right?
All right.
Now you know
We
the
joined up on the
professor feel,
Discord.
right?
Oh yeah, someone.
That's Roberto. I
Roberto.
Roberto.
Why did
Roberto, we're in the. If you go to the general, you'll see the invite.
No, he messaged it to him.
Yeah, I messaged him.
No, he's
I
on
messaged
the
it
homework.
to him already.
All right. Roberto, join up. Okay. So now we're gonna do problem 2. So
Also, deafen and muting yourself on Discord before you join the Zoom call.
all right, Roberto, you're in. Okay. So F. So we're gonna.
So now we're doing number
the
2, right?
We're doing number 2. We're gonna break the.
I'll be back again.
We're gonna break the A vector, B vector, and C vector into its component vectors in the X and Y directions because they're easy to add. All right.
Wait,
So first,
can you repeat that? I didn't hear you.
so we're gonna break down vector A, B, and C into their component vectors, into 2 vectors, horizontal and vertical, so they're easier to add. Does that make sense?
Yeah.
All right, beautiful. So
Okay.
vector 1, or vector A might be.
Okay.
So vector A is bam, bam, bam. I'm gonna draw a little arrowhead right there. It has a length of, I'm just gonna use F because, you know, F equals force. That's how we normally do vectors in structural, I assume. F is equal to half an inch, 0.5 inches. Oh God, that's not right. 0.5 inches.
Man, trying to tell us it's 5 inches.
And theta, which is the angle, is going to be 15 degrees. So this angle right here is 15 degrees. So now we're going to break it into its component vectors. We're going to need F sub A x, and we're going to need F sub A y. Right? So we're going to get the force vector of A in its x component, and force vector of y, force vector of A in its y component. So we're basically getting this vector right here. We're also getting this vector right here. Cool. So how do we do that?
So we're turning it into a 90-degree triangle.
We're turning it into a 90-degree triangle. And what's a right triangle's best friend? Trigonometry. We're going to use trigonometry. So F sub A x equals F sub A cosine of theta, right? We're taking the cosine, we're taking the adjacent side right here. So if this is theta, this is the hypotenuse, this is adjacent, this is the opposite. We're taking the adjacent side, we're taking the x component. Fa cosine equals 0.5 inches times cosine of 15 degrees. Pull out your calculator. Turn on your calculator.
Because cosine is opposite over hypotenuse, correct?
Cosine is adjacent over hypotenuse.
Oh, okay. So A over O.
A over H.
A over H. Adjacent over hypotenuse. And now sine is opposite over adjacent. I mean, sorry, opposite over hypotenuse, right?
Yeah. So if you look at this, just like real quick, FA times adjacent over hypotenuse. This is cosine, right?
Yeah.
FA is H. So by multiplying FA by cosine of theta, which is A over H, these cancel out and you're left with A.
Ooh.
Let me say that again. cosine of theta right here is equal to a over h. So how do you get a? You just multiply a over h by h. H times a over h. What is h? H is f a. That's this vector right here, the vector we started with. Times, what's a over h? Cosine of theta. See? See how these relate? See how this is the
Yeah.
exact same as this? How we got from here to here?
Yeah.
All right. Anyway, this is something you probably should have learned in pre-cal, but you know, I'm just going over it because
So A is going to equal f of a cosine theta.
yes.
All right.
So 0.5 times cosine of 15 degrees. You can get 0.483. Right, approximately. Now we need FAY. FAY equals FA sine theta. Now it's the exact same thing as finding FAX, but we're using sine instead. So just real quick, sine of theta is equal to opposite over hypotenuse. We'll multiply that by hypotenuse. Hypotenuse is f of a. Those cancel out. You get O, which is this y vector. So that's 0.5 inches times the sine of 15 degrees. Plug that into your calculator. You get approximately 129. Cool.
Wouldn't that be 0.13 though? Because you would round up because of the 9.
You can if you want. If you're rounding to two significant figures, I'm just using 3 just for accuracy.
So,
But it doesn't.
Okay.
Yeah.
Yeah.
You can do that.
So now our f of ay is 0.129 inches and our f of ax is 0.483 inches. Yeah.
Yes, sir.
All right.
Our f of ax is equal to 0.483 inches, and our FAY is equal to 0.129 inches. Everyone understand?
Yeah. Yeah. Okay.
Beautiful. If you don't understand, please speak up.
Yeah, for real. Like for real. Because like probably maybe someone else didn't understand it either. And you
Yeah.
just didn't name it, yeah.
All right. So now we're
Oh,
just.
by the way, you can write if you want. You can just write on the side SOHCAHTOA. You know
Oh
that,
yeah.
right?
Yeah.
Yeah,
Oh,
that helps a lot.
Yeah.
It
I'll
helps
just-
me a lot. Yeah. So
Yeah,
is
that's,
it it's
I use it
F-
always.
Is it SOHCAHTOA, right?
Yeah.
Oh yeah, it is that.
Like the
Uh,
first thing I wrote down.
Toa.
I wrote SOA instead of SOH.
SOHCAHTOA.
There we go. Okay.
You have,
I
like,
like
Kind of sounds like Sacagawea.
yeah.
I honestly I mixed those up. I thought SOHCAHTOA. Oh, that's the person who helped Lewis and Clark.
I actually like the way you're written it. I'm gonna write it like that now.
That's always how I write it.
I need to write it like that.
Toa.
Yeah, I write it stupid now, but I'm writing it like this, the way you wrote it, because that's way better.
All right.
Okay.
All right. So I'm just gonna speed through the next few ones because it's the same thing. Now we have B.
Oh right. So now we're doing B. Okay.
Okay, I'm actually gonna slow down a little bit on this one because there's a little interesting thing with this. All right. So this is theta right here. All right. F sub B is equal to, I should have put F sub A, so over here, but you guys can forgive me for that, I hope. F sub B is 0.75 inches, and theta sub B is 45 degrees. Cool. Let's draw the triangle. All triangles, there's always all right triangles. We'll do in trigonometry, there's always a right angle right there. There's our right angle. There is our theta. So now we need to find the x and y component. be cautious because this angle isn't good convention, to be honest. So we're just gonna write. So we're just gonna label hypotenuse opposite adjacent. All right, hypotenuse opposite because it's opposite the corner right there. Opposite adjacent because it's right next to the corner. Cool. So now we need to know what FBX is equal to, and F sub BY is equal to. Cool. F sub BX is equal to F sub B cosine of theta. Hold on, that's not correct. Cosine of theta finds the adjacent right here. Because we're looking for FB sub X, we can't use cosine because that would be finding the vertical right there. You would actually have to use sine theta
Good
because
thing
it's
I
the
used it.
opposite. Usually, if your graphs are labeled properly, you can always use cosine for X, sine for Y, but this isn't labeled properly because I guess Klebus just wants to play with triangles instead of 225 degrees. So FB subs sine of theta.
Oh, I get it, right? Because the angle would have been 225.
Yeah.
Correct. Correct. But this
25.
this guy wants to give me
So-
headache.
Yeah,
Sine
because now, like, imagine if someone, because normally you'd say adjacent over hypotenuse, right?
Yeah.
Wait, where are you guys getting 225 from the angle from?
Okay, so this.
You don't. Oh,
Right. So normally 225 is using the unit circle
Mhm.
as the basis, starting from this x, this positive x-axis, and going counterclockwise.
Oh, that's
This
right.
is 225 because this is 45 because 90 minus 45 is 45
Yeah.
plus this 180. 180 plus 45 is 225.
So if that was the case, 225, then we would do cosine.
Yes.
Yeah,
Oh,
yeah.
okay.
But Klebus decided to make life hard. That's what I'm seeing. Like he's
So
really-
like what he's trying to do is he's trying to make sure you understand what cosine and sine do. They don't just give you the x value, they give you the opposite or the adjacent value respectively.
I see.
So
I completely forgot about the unit circle.
So-
Ah, like, wait a
so
minute,
the
what-
reason why, I don't know if you guys ever noticed, but whenever Klebus is solving for a moment, he always does counterclockwise as
Because it's-
positive.
Because it is
This-
positive.
Yeah, this is
Yeah.
where it comes from. The unit circle, it
Yeah.
goes counterclockwise.
Yeah, because the top right is quadrant 1, right?
Yes.
And then
Yeah.
Top right quadrant
yeah,
1,
yeah,
2,
yeah.
3, 4.
4.
See, I remember pre-cal.
Yeah.
I remember a little bit.
All right.
Semester 1, freshman year.
All right, so we put
Hey,
that into our
yeah.
calculator. Let's get back to the problem. Put that into our calculator. 45 degrees. We get point
Wait, that's
5, 3.
that's cosine.
Yeah. It actually doesn't matter because it's a 45-degree angle and both sides are the same. All right, so so if you do mess up the cosine sine theta, it's fine on this one because it's a 45-degree angle. Both sides are the same. So you get 0.5303. 0.530 inches. What's wrong with that?
Nah,
Our
it's
vector is
positive. Yeah.
Our vector is going into the third quadrant.
Negatives.
It's got to be negative.
Mm.
Positive, positive, negative, positive, negative, negative, positive, negative. So the reason why we get a positive answer is because we're using this 45-degree angle. So just look at this triangle. Just don't worry about the graph. Look at this triangle. You wouldn't need like a negative measurement value, do you? No. So it just gives you normal 0.530. but now we put it on the graph, it's going in the negative direction. So we do negative 0.530. Does that make sense?
Yeah.
Does that make sense for everyone? If it doesn't, speak up. All right, cool. F sub b y, do the same thing. F b cosine of theta, because now we're doing adjacent. So ka a over h. FB 0.75 inches, sine of cosine of 45 degrees. You get the same exact answer. 0.530 inches. But it's negative because it's going down into the third quadrant. Both measurements are negative. Beautiful. Now we did that one. FBX is equal to negative 0.530 inches. That's sweet. And FBY is equal to negative 0.530 inches. Does anyone not understand?
It's
Beautiful.
starting to come back to me. It's just been a while since I've done pre-cal,
Yeah, all right.
or have had to actually do it.
I completely understand. All right. Let's do the third vector, or the cth vector, the c vector. All right. I'm just going to go through this real quick. F sub c is equal to 1.25 inches. Theta sub c is equal to 60 degrees. We now need to find, we need to break it into its component parts. F sub cx is equal, what does that equal? F sub cy is unknown. Cool. Let's do this. FCX. You know what? I'm just going to type it out to make it faster. F sub cx is equal to F sub c cosine of theta. Oh my god. All right. FC is 1.25 cosine of 60 degrees. 1.25 cosine of 60 degrees. That would give you 0.625. Such a nice number. See how round that is? 0.625 inches. Let's do the same thing for y. F sub cy is equal to fc sine of theta. Keep doing tab. Equals fc sine of theta. So now it's going to be 1.25 sine of 60 degrees. Put that into our calculator. I'll just grab that. Put that as a sine theta. And then we get 1.0823. 1.083 inches. Beautiful. F sub cx is equal to 0.625 inches, and F sub cy is equal to 1.083 inches. All right, I know that was a little fast, but does everyone follow along?
Yeah.
All right, beautiful. Now, we did all the hard stuff. Now we have to do more hard stuff. Not really, but we got to add these together. We need to know what F sub r stands for resultant. This is the big vector after you added a, b, and c. F sub r, what was that equal? It was theta sub r equal. So let's start off by adding all the x's together. F sub r x equals f sub a x plus f sub b x plus f sub c x. we grab that boy, and that boy. Be sure to minus this from what you're adding because it's negative. So we could just do that in our calculator. 0.483 plus negative 0.530 plus 0.625. That should give you 0.578. 0.578 inches. Yep.
Yeah.
F sub R Y. Fry. F-A-Y. Fay. That's not right. Oh my god. Hello.
Tom Fay. Remind you of anyone?
F-B-Y for B plus F-C-Y for C. All right. And we add these bad boys. Be sure
Turn on the
to add
please.
the negative right there. Be mindful of negatives. 1.25. We can minus as well. We don't have to add a negative. We can also just minus 0.530 plus 1.083. That should give you 0.682 inches.
Thank you.
Beautiful. FRX is equal to 0.578 inches. FRY is equal to 0.682 inches. We're almost there.
Wait, hang on. It's in
What's up?
with that 0.129. Why did you put the minus instead of a plus minus, or it doesn't matter?
So 0.129 minus this 5.30. We minus because 0.530 is a negative. See that negative sign right there?
Oh, okay. Yeah.
So you
'cause
can so you see what I did here? You can either add a negative or just minus the number.
okay, yeah, that got me off guard for a second. I was like, wait a minute.
So yeah, if you have a smart calculator, it doesn't matter if you're doing negative or not. If you add in the negative, but make sure it's negative and not the minus symbol. That's a little complicated. I shouldn't have gone into that. Anyway, everyone understand?
Oh, yeah.
Beautiful. So now we have Fricks and we have Fry. How do you get fur? You guys remember Pythagorean theorem? F sub R equals FRX squared plus FRY squared. Why does this work? Because, let me just draw a right triangle real quick. FR, we have FRX, and we have FRY. Beautiful. That is our vector. These are our component vectors. We do this one in red because this one is important. This is the one we're looking for. These are the ones that we already have. Pythagorean theorem. This side squared plus this side squared is equal to this side squared. Why does that work? I don't know. It's pretty cool. Pythagoras figured it out. Cool. So that's red. FR. Now how do we take off the square? We have to square root the entire equation. We have to square root this side of the equation and this side of the equation. So FR squared, square root is just FR, equals square root of F sub Rx squared plus F sub Ry squared. Beautiful. We just add this. Let's just do that. Square root of FRX is 0.578 squared plus FRY, which is 0.682 squared. That gives you your answer. FR is equal to. FR is equal to 0.894. That's slightly different from what I got, but it doesn't matter. It's just rounding. 0.894. That is the answer I got. So now we know FR is equal to 0.894. Beautiful.
Inches, right?
Inches.
And that's it. Isn't that he wanted the length of FR.
Does he say he wants theta? Because I think we can figure it out at this point.
No, we can. We
Wait,
can.
hold
No, I'm saying does he?
What
Is it
does
in the
it say on
PDF?
the sheet?
Yeah.
It says add 3 vectors above mathematically, so I assume he wants theta. Let's just put it in just in case because we can do that very easily.
Okay.
I will help. I will guide you through it. I'll help you guide you through it. All right. So remember our right triangle that we made. All right. So we have f r x, f r y, and we have f sub r. Right. This is a 90-degree angle. This is the angle we're looking for because that's where it lies on the grid. Okay. So now we gotta use some more trigonometry, right? This time we're gonna use TOA. We're gonna use tangent. You can use the other ones, but this will be easier. So we're gonna use tangent. So we're just gonna label this real quick. This is the hypotenuse. This is the opposite, and this is the adjacent. So we already have our frx and fry, which is our adjacent and opposite respectively. We also have this, but let's act like we didn't do this part. We only want theta. We didn't want this. So pretend this doesn't exist. We're just going to use these values. All right, this will make it easier. So TOA, sine, frick. Tangent
Boy, tangent boy.
of theta. Tangent of theta equals opposite over adjacent, right? It was right there. So tangent of theta is equal to f frick f r y over f r x. See, fry is opposite, frx is adjacent, opposite over adjacent, fry over frx. Now we gotta isolate the theta because we're looking for theta sub r. How do we do that? Inverse tangent. Take the inverse tangent. So inverse tangent of theta is just theta because those cancel each other out. It's like the square and the square root thing. Equals inverse tangent of fry over f sub r x. Now you don't really need these parts right here. This is the only part you need. But I just want to explain how we got there. All right. So let's just throw this off to the side. This is the formula we need. Theta is equal to inverse tangent of fry over frx. Beautiful. How do you get inverse tangent? You just use, if you have a smart calculator, you can use the second function on tangent. You can see the -1 right there. Now,
Actually, that's different on the Inspire. It gives you like a list option. It's pretty cool.
Yeah. All right, but on TI-84s, this is the way to go. All right, inverse tangent of fry, which is 0.682, over frx, which is 0.578. Boom, we have tangent. Oh god, tangent. Why am I saying tangent? Theta. I'm saying theta. We have theta is equal to 49.718 degrees. Yep. All right. Theta r is equal to 49.7. I'm just going to do 2 degrees. Let's round it up. And boom, there you have it. That's your answer for number 2.
Add the 3 vectors above mathematically. So the resultant vector is 0.894 inches long with an angle of 49 degrees.
Yes, 49.7, so 50 degrees if you want to round up.
Yeah, so that's the resultant vector.
Yeah.
Okay.
So let's just review how we got here, all right? We took the component vectors of each of these vectors, took the x and the y, the x and the y, the x and the y of each of these vectors using trigonometry to get the x components and the y components of each vector. Because now they're all pointing in the same direction, they're all pointing in the x direction, and they're all pointing in the y direction. We add all the x's together to get f sub r x, and we add all the y's together to get f sub r y, right? So we've added all the vectors together. Now we need to get the measurements. Use Pythagorean theorem on f sub r x and f sub r y to get f r. And we use inverse tangent on f sub r x and f sub r y to get the angle. Does everyone understand?
Yeah, yeah. Like understand how we got here? Yes.
All right.
Yeah. I don't know.
It's kind of a lot, but
No. I'm
We all did.
remembering more of pre-cal like something.
Yeah.
all right.
I have like a little flip sheet. Is there in my room that has like all the SOHCAHTOA and everything in the unit circle that I could review back on if I ever get stuck again too.
All right, beautiful. Does anyone not understand? Splendid. All right, cool. Well, next problem, number 3. All right, now we have to do, what is this called? Equilibrium stuff? I think it's called equilibrium. Anyway, so number 3, we have a pin. Well, first off, let's draw the beam. We have a beam right here, right? We have a pin on one side
And a roller on the other.
and a pin roller on the other side. Coolio. All right, so now we have a kip force of 3.2 kips right here. And we have a force of 1.6 kips right here. We're gonna call this place A. We're gonna call this place B. We're gonna call this place C. We're gonna call this place D. How far are these away from each other? Well, this is 5.2 feet. 6.8 feet. You know what? I'm just gonna make these pretty. Gonna type these out.
Oh dang.
All right. This bit is 5.2 feet. This bit is 6.8 feet. This point is 4.5 feet. This is 1.6 kips. And this is 3.2 kip. Am I doing anything wrong? It looks all right. All right, cool. Now that we got the problem, in the simply supported beam below, we calculate the vertical reaction at point D. So, for pins, there are 2 reactions. There's a reaction in the x direction. How did I notate this? There's a reaction in the x direction of A, and there's a reaction in the y direction. I'm going to make this a different color so it pops better. Cyan. R sub x A and R sub y A. Rollers, there's only one reaction, so it's just R sub y D because it's at point D. All right, so we got everything we need. We need to calculate vertical reaction at point D. We are looking for R sub y. I thought I changed to black.
Cyan sus.
R sub R sub yd is equal to, this is what we're looking for. Cool. Now I can go full screen. I got more space to work with. This is absolutely splendid. All right. So we got this. Now what? Start taking summations. All right. Sigma f of x. We're taking the summation of all the forces going in the x direction. Luckily for us, all these forces do go in x and y directions, so we don't have to do any trigonometry like we did in the second problem. F sub x equals to, where are all the horizontal forces?
X equals 0.
Oh, yeah, x equals 0.
Oh, yeah.
But there's only one force going in the x direction. That's r sub x a. 0 is equal to r sub x. Oh. R sub x a is equal to 0. Wow. 0 kip.
Oh, that's because there's no kips being applied to that direction, correct?
Right. Because we're assuming that this body is in equilibrium right now. So we assume that all the x forces equal to 0. Since this is the only force, it has to be 0. Because if it's not 0, then the body would not be in equilibrium. So Rxa is equal to 0 kip. Cool. Everyone get that?
Yeah,
Alrighty-o.
because it's only in one direction.
It's
not
only in
normal.
one direction. And there is only one force. Cool. I think I'm going to keep this on the screen.
Just for shits and giggles.
Let's just make it smaller. All right. So now we do summation of f of y, all the forces in the y direction. Okay. So 0 is equal to, let's just count them all. All right. So before we move on, we have to establish a ground rule. Let's say all the forces moving upwards are positive, right? So how Cleppis does that is he just does an arrow right here. For sub x, he just does the arrow up here. But anyway,
Wait,
all the
quick question. What's that at the end of the Y right there on the?
oh, it's just an equal sign. It's how I notate.
Oh, okay. I was just like, is that an equal sign or something else? I got
So it's
confused.
like an equal sign with an arrow. That's just how I notate.
Oh, okay.
Because f sub y equals 0 equals, there's two equal signs. It's not an equation, you know. So it's just a notation. I'll just keep as a regular equal sign, just so it doesn't confuse anyone. So summation of all the forces in the y direction, assuming that all the forces going up are positive. So let's just scan this real quick. Oh, there's a vertical one right there. R sub y a is going in the up direction. Okay. Let's go over here. Oh, there's a 3.2 kips going down.
So negative 3.2 kips.
Minus 3.2 kip. Next one, 1.6 kip. It's going up. Plus 1.6 kip. There's one right here. Reaction going up. Plus r sub y d. This is what we're looking for. This is what the problem is asking for. So let's just simplify. 0 equals ry a plus, that looks terrible, ry sub a plus r sub y d. So I'm just going to put all the unknowns on one side, and then minus 3.2 kips plus 1.6. What does that equal? That equals minus 1.6 kip. All right, cool. So now we'll just move 1.6 kip to the other side. 1.6 kip equals R, Y, A plus R, Y, D. Boom. We can't do any more. Have to keep this in our backlog. Now, like, why did this negative become a positive? It's just basic geometry. You're adding 1.6 kips to both sides. So that's why this is positive and it's negative over here. Beautiful. So now we have a fun equation to use. I'm just going to flip it around for notation purposes. R sub YA plus R sub YD is equal to 1.6 kips. Let's keep that in our backlog. Remember that for later because we are going to use it later. All right. Just make that smaller. Now we are going to do, we still haven't gotten anywhere. Solve for RXA, but it's not useful in this equation. And we have two unknowns in here. You can't do anything. What's the next thing you can do? You can solve for moments. Summation, oh god. Summation of moments. Assuming going to the counterclockwise direction is positive. Equals 0. Actually gonna move this over down here. Just gonna move this off to the side real quick. Can y'all see behind this weird window right here?
What weird window?
Okay, so can you read that?
I can read that.
I can read that. I can read the RXA stuff.
Okay, cool. Because this is where I'm putting all the other faces, so I can see everyone's smiling faces as we do some tech homework.
Gotcha.
All right. Summation of moments, assuming counterclockwise, is positive. Equals 0 equals. So how do we take moments? Moments are taken in the units of a force times a distance. In this case, we're going to use kips and feet. So we're going to take this force, R. Okay, I should clarify. We're taking the moments at D. Why did I do that? I'm not sure exactly. I think it's because we're looking for RYD. So it's just easier that way.
Yeah, we're looking for the vertical reaction at point D.
We're looking for the moments, summation of moments at point D.
Right.
So we're looking for what's happening at D.
We're looking for what's happening at D.
Okay.
Right there. We are looking for what is happening here. So there is a force right here. R sub Y D times a distance. How far is it away from D?
Wait, 4.5 feet.
It is 0 feet because it's pointing
Oh.
directly at D. 0 feet times 0 feet. So this doesn't matter.
I got confused for a second when you said one. I was like, wait a
Alright.
minute.
Next one. 1.6 kips. So it's pushing in this direction. Now which way is that gonna turn?
Counterclockwise. I mean, clockwise.
It's gonna
Oh, it
turn
could be negative.
clockwise, right?
Mhm.
Very right. It's pointing at this. Right here. Clockwise. It's gonna go clockwise. So clockwise is negative because counterclockwise is positive. You notate that there. Counterclockwise is positive. We're going clockwise, it's gonna be negative.
Think of your
Minus
circle.
1.6 skip times 4.5 feet. You can use parentheses to multiply things together. Cool. Next force, 3.2 kips. Where's this way rotating?
Positive.
Positive. It's going counterclockwise. See, it goes down, so it's gonna go around D, right? Counterclockwise. Plus 3.2 kip times how far is it away from D? Just gonna add these two measurements together. It's this measurement plus this measurement. It's that far away from D. Gonna turn on my calculator. So 6.8 feet.
11.3.
Wow, you are so smart. Faster than the calculator. 11.3 feet. Let's go to this one. RYA. I'm just double checking to see I'm going the right direction. Obviously, I could be wrong. I could have done this problem wrong, but I double checked. Hopefully, it's correct.
No, you don't do problems wrong, Edison. Klebis does problems wrong.
Oh boy.
Yeah. That guy.
Whoa. That's a big shade,
All
man.
right.
Whatever.
Kinda
Back to the
shady,
homework.
bro.
Back to the homework. Back to the homework. Let's go.
This ain't a roast session.
Oh my gosh. Okay. This is another force. R sub YA. RYA. Hold on. It's going in the negative direction because it's gonna go clockwise. Bam. So minus R sub YA times how far is it away? It is 16.5 feet.
So at the moment, this is basically just one really long chain. You just put the 3.2 in the bottoms because it would fit.
All right, now there's one more force. All right, so we're gonna add this force right here. Actually, we don't know if it's going clockwise or counterclockwise. So we're just gonna write it real quick. R X A times how far is it away from D?
So it's all those lengths together, right?
So 11.3. So that's 16.5.
It's pointing straight at D. It's pointing straight at D.
Yeah.
It's not gonna go anywhere. Let's take this
And
pencil, for
you're-
example.
Oh, yeah, you're pushing on it. Like there's
Say-
no.
Yeah, right. This
Yeah.
is D.
Yeah, I see what you.
This is C. Gonna go
mean.
clockwise. This is B. It's gonna go counterclockwise. This is RXA.
Oh.
It's not gonna turn. The same thing with RYD, the very first one we did. It's not gonna turn because it's pointing straight at where we're measuring the moment.
I thought we were still calculating the length of the whole thing. That's why.
So one thing that you can do, if this is too complicated, you just don't mind what I say. But what I like to do is I like to extend the force vector. Extend the force vector. So this is RXA. See how it passes through D? It's going to be 0 feet. Extend RYD. How it passes through D? 0 feet. Extend C. It's going beside D. Now, the shortest path from D to C is going to be perpendicular to C. So it's 4.5 feet. B misses D. This length right here is the shortest length because it's perpendicular. That would be 11.3 feet. Same thing here. Or wait, it doesn't meet D. It's this entire distance right here. If that didn't make sense, don't worry about it. It's just another way of thinking. I think in a lot of ways. Just choose whichever way fits you. All right, anyway, RXA, that's going to be 0 feet. You can just plus that. Beautiful. So now this one doesn't matter, and this one doesn't matter, because they're multiplied by 0 feet. 1.6 kips times 4.5, that would be minus 7, make this more beautiful, equals minus 7.2 kip feet. Plus, we're gonna multiply 3.2 by 11.3. We're gonna get 36.16 kip feet. This is an approximation because there's a lot of decimal points. Kip feet. And then we're gonna multiply these two together. Oh wait, we can't. Minus r sub y a of 16.5. R sub y times 16.5 feet. Cool. So now we're gonna move this thing to the other side because it has an unknown. There's only one unknown, which is amazing for us. So we can solve for r, y, a.
Was that RYA a negative on this side?
It was a negative on this side, so we add
Yeah.
it to both sides, so it becomes positive on the left side.
I got you.
So we add these two together. Negative 7.2 kip feet plus 36.16 kip feet is equal to 28.96 kip feet. Beautiful. Now we divide both sides by 16.5 feet, so we're left with RYA equals approximately 1.76 kips. Why is it not kip feet? It's because we divided a kip feet number constant by feet. So let's just visualize this, 28.96 kip times feet divided by 16.5 feet. The feet just cancel each other out. So we're just left with kip, and then the constant, 28.96 divided by 16.5, we get 1.76 kip for RYA. Does this make sense for everyone?
Yeah.
Beautiful.
Wait, so you got wait. RYA 1.76. Yeah.
1.76.
Got you.
This was just a visualization of why we got feet instead of kip feet.
Got you.
All right, beautiful. Now, we can do this equation. Remember this equation that I told you to keep in your backlog? We're going to use it now because now we know R sub YA. I need more room. I'll just move this boy over here. And we're going to use this space right here. So now, we're going to use this formula. Bam. RYA is equal plus RYD is equal to 1.6 kip. Cool, now we plug in RYA. 1.76 kip plus RYD is equal to 1.6 kip. Cool. We minus 1.76 kip to both sides, and we're left with RYD is equal to negative 0.16 kip. I'm not joking. 1.6 minus 1.76, you get negative 0.16. Now, how can a force be negative? It's not like you're pushing with bad force that so weak that you've gone into negatives. You're actually going into the opposite direction of which way the vector is pointing. So you see how RYD is pointing up right now? This RYD pointing up is pushing, quote unquote, pushing with a force of minus 0.16 kip. It's a little weird. Let's think about it another way. Remember when we were adding we're taking the summations of all the forces in the y direction, how all the positive forces, or how all the forces going up were positive and how forces going down were negative. So this is a force going up that is negative, but it is the same thing as a force going down that is positive. And that's a little confusing. I'm just going to draw it down here. This force of negative 0.16 kip is the same as this force with 0.16 kip. It's going in the opposite direction now. You can also see this as, so you see how this is pushing with 1.6 kips. You can also pull with 0.16 kip. I think I misspoke earlier. 0.16 kip. Does that make sense?
Yeah, I can see that.
So you're
You could
pushing.
also-
Huh?
No, I was just gonna say you could also talk about the 3.2 and how eventually they all equal 0.
Right.
remember?
Yeah, I remember that. So this is pointing up with minus 0.16 kip. It's the same as if you just flip it and then change it to positive. It's as simple as that. So for the worksheet, make sure you notate which way your vector is pointing. Make sure you notate that. So this is correct. Pointing up with a force of negative 0.1 kip, 16 kip. You can also notate as pulling for positive 0.1 kip, 0.16 kip. But we're just going to keep it simple. It's going to push up with a force of negative 0.1 kip. So here's another way to think about it. I'm gonna draw this up here. Let's say this is our beam, right? There's a force right here. 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 This is another way of thinking about positives and negatives. So there has to be 3 forces to equal 1 force, right? Because the body is not moving, it's stationary, it's in equilibrium, it's not moving, all the forces are equal. All these forces pointing up should equal this one force pointing down. This is 3.2 kip. This is 1.6 kip. And now these two should add up to 1.6 kip. This is the exact same formula we have. So it's pushing up with 1.6 kip and it's pushing down with 3.2 kip. We need an additional 1.6 kip pushing it up, spread across these two vectors. So like this can be 1.6 kip, and this could be 0 kip. Or this could be 0.8 kip, and this could be 0.8 kip as well. This could be 11.6 kip, and this could be negative 10 kip. Point is, these have to add up to 3.2 kip. So what did we get? 1.76 kip and a negative 0.16 kip.
I feel like we round it too much because it doesn't equal 3.2 exactly, but
Doesn't?
it's close.
Huh?
I think we probably rounded too much in the beginning.
You're saying that the negative 0.16 doesn't like add up to being 0?
No, because then it becomes
What?
Oh no, it adds up because
It adds
becomes
up.
1.6 and 1.6.
Oh, it's because you kept that as negative. I forget.
Negative. Remember,
you
this is a
Christian
negative.
Dennis?
Yeah, I was
Christian.
like, wait a minute, hold up.
Oh
You're trying to,
you're
you're trying
right.
to connect me a little bit.
Wait, why'd you leave 1.76?
Because that's what
That's
we've
that
got.
one. That's
Yeah,
our.
that was
RYA.
positive. Oh,
That
I
one's
have
positive.
I have my signs wrong. Bro,
This
Yeah, I'm
one's
about to
positive.
say, yeah, that's
one's
RYA,
negative.
right? 1.76.
Yeah.
yeah.
And the
I put
RYB
negative.
Oh, you tripping, bro.
All right. Is everyone clear on how this
Yeah,
works?
Yeah.
So like you could also see this, we could transition this to the other side. Remember we're flipping the negatives, so now it's pointing the opposite direction. We flip the sign. 0.16 kip. So now these two equal these two. And the math does 3.36 kip, pointing down. And 3.36 kip, pointing up.
Done.
I bamboozled myself.
Done deal right
You
there,
did
buddy.
bamboozle yourself.
Everyone understand?
Yes.
I was understanding, then I was like, wait a minute, and then yeah, I understand again.
Everyone understand? Everyone understand?
No, but
Beautiful.
good question, Dennis. Like, we
Thumbs up
understand.
if you understand.
All right.
Okay.
Are you good to move on the final question?
Yeah.
I know I'm just giving you guys the answer, but I think learning is
No, this is helpful.
the
Yeah, this is
correct
like-
way to go.
Honestly,
I-
like,
I learned
actually have
before.
notes this time.
Right. These are notes. These are my notes now.
Our notes.
I wrote in class. He did it wrong. Whatever he did it wrong. Like it was just a waste of time. It's fast. These are my new notes that
Like
I'm.
honestly, in class, like you can barely see like half the notes half the time because
I'm
he's
wasting
blocking the board.
$2,000 on those fools. I'll be honest. Whatever I'm.
I was kind of upset when I think, who was it that mentioned? It wasn't Edison, it was somebody else that caught it.
Jocelyn, I think she was like, "Yeah, professor, this is wrong." And I looked. Then I started really paying attention. And I'm like,
Bro,
"Oh
for
my
real.
God." And I started looking. And I'm like, Jocelyn's right. And I was about to. And then he realized too that he had his fuck up moment. You know,
Because
Like,
he
the
used like
second he-
old stuff. And I was like, wait, what? Everything's wrong. bro.
everything's wrong. As soon as Jocelyn said it, I went in and I was like, "Oh my God." Like I
the
face
second I
palm
said it was wrong. I was like, oh, I'm done for the day.
Well, no, I started checking at that point. Then
I think everybody just like bro.
But
like,
yeah, most other people at that point they just clocked out. They were like, "Yeah, fuck this."
All right.
You
I know
can
I'm
fix it.
taking like a long time, but
No. That's
No, like
No,
take
no,
your
this
time
is
as
good,
no
take
bro.
your
problem.
time. Yeah, take
I
your
I
think
time.
didn't even
it's
realize it's
important.
already 8.
Are
Did
you
not
busy?
realize.
Do you have somewhere to go, Edison? Or are you
Yeah,
good?
do you
no,
need
I
to
just
go
have to
somewhere,
eat
my dude?
dinner. I'm a little hungry,
got
but
kids to
this
take care
is
of,
super fun
Edison?
for me. This is
We
fun
can
for
leave
me.
right now,
Honestly, you
Edison.
guys want to take like a 10-minute break so we
No.
Edison
He
can
has to
eat
eat
real
dinner, so we're gonna finish problem 4, and then Edison's gonna go eat dinner.
No,
Go
we
finish
can
problem
finish
4.
it tomorrow. We can come tomorrow. It don't matter, Edison. Take
No,
your
no.
time.
I'm completely fine. I like doing this. I like teaching. I like math.
This is his strength, Dennis. This is his strength right here.
Splendid. Let's continue.
Splendid. Hey, I
That's his
use that word.
That's his
That's
word.
my word.
Yeah, that is the word.
That's his
Word
All
of the
right.
day. Splendid.
Let's go.
Splendid.
Let's
All
go.
right.
Quick question: when we turn this in, how do we turn it in? Do we just like go
You're
on?
gonna
So what I
scan
did-
your- Oh well, yeah. Let Edison tell you.
So what I did is I printed it out, and then see I did all the notations right there.
Oh, he did the work on it. Oh.
Oh, okay.
I didn't scan this. I didn't
did you-
submit this. I only submitted this. So this is with all the work. This is adding it graphically. This is A, B, C. This is all the work for adding vectors. And then for 3 and 4, I just redrew the things, the bodies. I redrew it here too.
Yeah, so I'm pretty much just gonna write the word answer, put it the answer right there, and then the rest of it's the work, and just scan all my notebook pages.
I just usually put my answer in like a little box like that. Honestly.
Yeah, so yeah, that's
They don't like that. They will clap.
They don't
you,
like that.
Santos.
Yeah, they don't like
They
that.
will
So
clap you,
I'm literally
Santos.
gonna have an answers page. There will be a separate page titled answers that will have
Yep,
every
yep.
answer, and then
Oh.
the rest of this bullshit will be work.
Wait, so they don't like putting in boxes? Because that's why I did
No,
in calculus.
No.
That's fine.
Bad
but, like,
teachers
you need to-
Clapped me, bro.
Yeah.
They said,
Okay, my calculus
"Don't
teacher
box."
wants us to box our answers.
Yeah, he
Bruh.
wants us to box our answers, but he wants it I'm trying to make it as easily visible to him
Okay.
as possible.
Yeah.
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 No,
Yeah,
because I honestly
boxed it,
just boxed-
highlighted in red, yellow.
Yeah, so like in the third problem, I boxed my answer and then I rewrote it
Perfect.
Yeah, you would get
RYD,
clapped.
bam.
You would get clapped by my high school.
And then
pre-com.
In your high
then,
school
like,
teacher,
make sure
Yeah.
Wah.
you
The
notate which
notation.
way
Yeah.
the vector is going.
So Edison, I think you're fine because you like dark boxed it out. You're good. Like I'm
Yeah.
gonna do pretty much the same thing.
I'm just like, I don't do that habit anymore, bro. I'm traumatized.
Yeah.
Well, if you don't do
like-
that, then make sure you like
No, I'll
the
do what
answers
Imran did.
page.
Yeah. I'll do
Okay,
what
yeah.
Steph
I'm
did.
gonna
I
have
think
my
I do what Emron
answers
does,
page,
'cause
and
I'm
then the
kinda
rest
gonna
of the
do it
thing.
be
is
like, wait a minute.
all right.
Yeah. So all the answers are on one page.
Kind of like how I
all the
did an
work is
answer
on-
key and then put all the work in the front.
Yeah,
Pretty
yeah,
much,
yeah.
pretty- that right there. That's
all
it.
right.
That's what I'm trying. So number
So
four.
so we
what-
just so basically we're just gonna be scanning our notes and then an answer sheet in the back.
Yeah,
Yeah,
correct.
y'all,
correct.
y'all disconnect from the Discord call, I guess.
Yeah, we don't even need that whole.
Yeah.
That's fine.
We're just wasting our time on Discord at this moment.
Yeah, you're
What do you
using
mean,
you're
wasting
wasting your bandwidth. All right,
I
number
am.
4.
Yeah,
Number 4.
Number four. Yeah, so
Number 4. Is there anyone in the waiting room? No one's in the waiting room.
Now hold on. Number 3 was calculate the vertical reaction at point D. So that's RYD only. That's what he's looking.
Only RYD.
All right. So now, but number 4 is asking something else. What is it saying?
It's asking for the horizontal and vertical at point A.
So RYA RXA. Okay. Okay.
Yeah. I think I'm just gonna take a screenshot and then just plop it in here.
Dang. That Emron bending over though screenshot.
All right, so there is our problem.
That's Santos.
Now we need the drawing space or
Man,
the whiteboard space.
this guy's an expert at MS.
Bam. All right, that's enough. That's
Bro, what do you
plenty
mean?
of
This
space.
ain't MS Paint. This is a fucking whiteboard. What are you talking about?
Yeah, this is my
That's what I'm saying.
whiteboard.
Yeah, yeah,
What
man.
is
What is Klebus doing?
it says Professor's Chew whiteboard. What you mean, bro?
Hey, Professor Edison, I don't have a teaching certificate. You can't
Oh.
legally call me Mr. Chu. You have to call me
Professor
Mr.
Ed.
Nah, his name is now Mr. C. I'm gonna call him Mr. C.
Mrs. C.
Call me Ted or something. I don't know.
Oh, bad.
Oh,
Professor
Ted, hey,
Ted.
the bear from Ted. The bear from Ted.
I'm dead.
All right, so we got this. We can go full screen.
Give me 1 second to draw it real fast on here.
Yeah. You know what? Should I just draw it, just so I can draw it with you guys? I'm
But
gonna
you've
draw
already
it.
drawn
No,
it.
no. You're a professor. You do what you gotta do.
All right. All
Oh,
right.
you want to redraw it? Oh, I understand. Okay.
Santos just gotta be quick.
All right, Santos, you gotta hurry up. These lecture notes aren't gonna write themselves down, I guess. Well, it's being recorded, so
Technically,
technically they are.
technically.
They're already
Technically,
writing
they're
themselves
being-
in the recording. All right, beautiful. So, pins. Two resultant vectors or reaction vectors. I think they're called reaction vectors. One on the x, a x. That's not x. R8 y. And then boom. R A X. This looks terrible. I don't like this. I'm gonna redraw it.
Hey, someone's rolling coal over here.
So, bam, bam, bam.
Man, even Professor Ted's going faster than me when I'm drawing.
It's a little,
Hmm.
it's a little hangman thing.
Yeah. So after I'm done my tech homework, you know where I'm gonna hang.
No.
Ah.
You already know, bro.
We're all positive here, bro.
You're right, Dennis. You're right. High five.
We're all positive here, bro.
Hold on,
Alright.
do you need a round of Minecraft to cheer yourself up?
A round of Minecraft. Maybe, bro.
There, you can do whatever you want. Yeah.
Right. Then I'll find a mountain and jump off it.
No. You gotta do a lava pit. You gotta do a lava pit.
Lava pit Minecraft.
Yeah.
No, just
Gotta watch
just
you
go to
burn.
the end portal and just break the
Yeah,
portal. and
yeah.
jump in.
No, yeah. I'm just gonna go to the void. Lost in the void, bro.
No, that's kind of harsh, bro. That's just out.
And in that time, Edison's drawn it nice. Awesome.
So we have a force right here of 18 kip. And we have what? We have a moment at C, or okay, I'm gonna label this. This is gonna be A. This is what given. They only gave A. So I'm just gonna label this B. I'm gonna label this C. Because there's nothing happening right here. So we're not gonna use that. A, B, C. I remember I used text. That's A. That's B. This is C. Beautiful. 18 kip. 12.8 feet. Oh, that's not right. 12.8 feet. 5.6 feet. 8.4 feet.
I'm 5'8".
I'm 5'3".
All the sadness. What about you, Emron?
What am I? What are you saying? What?
How tall are you?
5'11", 5'10", 5'10". I'm 5'10".
Dang.
I'm 5'6". I'm small.
So far, it's
I'm
Edison-
small, 5'3".
So Edison, Dennis.
No, you're
me,
tall,
and
big
Emron.
brain.
No. If you're above 5, you're Gucci. Don't worry.
Facts.
That's facts. If you're a dude and you're above 5, you're Gucci. Don't worry. Don't
All
stress.
right.
Wait, Roberto, what's your height? We gotta know now.
He's like the same height as me. Don't worry.
Yeah, I
Okay.
think Roberto's like everyone.
He like 5'10".
Oh
Yeah.
wow, you're actually here. Wow.
So
I
Yeah.
could have sworn you left because you weren't talking at all.
so Edison, and then Dennis, then me, then Roberto, and then Emron, because Emron's 5'11", right?
I'm in between 5'5" and 5'6", just so you'll know.
Oh, she's
dead.
taller than me. Hey, I'm the shortest guy here.
Oh,
Right,
she's
so-
tall, bro.
So Edison, Ali,
And
then
I-
Dennis, then
No,
me.
no, no, no. Edison's on top. He got the big
Edison's
brain.
on top. Okay, he
Okay,
just on
Edison-
top automatic.
Edison's on top, bro. Come
Okay,
on, bro.
so Ali,
Yeah,
then
yeah. Alex is
Dennis,
bottom.
then me, then Roberto, then Emron, and then Edison.
Edison, correct at the top, no matter what.
And I didn't think we got Ali jealous of us talking about our heights. Whatnot.
You know she has the voice in, right?
Y'all are
Oh, yeah,
actually
that's
making me
true.
blush.
Yeah. Dead.
All right, so rollers. There's only one reaction vector. It's perpendicular to the surface.
Bro, the way she pops up. Oh, got me dead.
And there's two resultant vectors. R X A. Oh god, R X A and R Y A. Beautiful. These are what we're looking for. That's why I marked it in red, just for visual sake. Cool.
It's sus.
Anyway, just gonna ignore that. I JK. Anyway. Oh my god, hold up. This is gonna be there. Alright, then I'm just gonna outline this in black. Alright, it's kind of hard to see. Cool! Let's take the summation of all the x forces in the x direction. F. Hold on. Okay, cool. Hold on, that's not right. Sigma. It's gotta be connected. Sigma. F sub x. So we're taking all the forces in the x direction. Equals. Where's the next force? Right here. R x a. We're assuming right is positive. So RXA is going to be positive. Plus, there's another one up here. RXB is equal to 0. I forgot that. So, just make this simple. RXA is equal to negative RXB. It's the same as RXA plus RXB equals 0. If you think about it, if RXA is 2, RXB is negative 2. 2 plus negative 2 is 0. Yeah, makes sense. So RXA equals negative RXB. Put that in our backlog. Gonna use this later.
I put it in my back pocket.
A quick question. You put those letters up, right? He didn't have that on his, right? Did he?
He only had A on there. I put B and
Alright.
C just so we're all on the same page. RX.
You can't put D.
You can if you want. Doesn't
Why
matter.
would you need
No,
it?
I'm just asking because like we're solving. We don't need to solve the one above it, right? Because it's standpoint. It's the same as C.
We don't
It's
need to
just-
solve this one. Talking about this one?
Yeah, we don't. That would be basically the same, right? Let's see.
So there's nothing happening there. There's
That's
no
all.
forces. There's no forces on it. There's no force. There's no moments on it. We don't need to worry about that. This
Think
force
of
is
it-
going to this point. These two forces are going to this point. This force is going to that point. Riguchi.
So think of
Alright.
it as just like a solid piece, just trying to be pushed up like that, kind of.
All right. Does that answer your question, Dennis?
Yeah, I'm good.
All right, cool. Let's move on. Now we did all the summation of the forces in the x direction. Let's do the y direction. Sigma F sub y, assuming, let's do up. That's a norm. That's pretty good. All vectors pointing up are positive. Equals. There's one right here. It's pointing up. R equals 0. There's one right here. R sub y a. There's one right here. Plus, it's pointing up, 18 kip.
For a second, I was just like, "Where'd you get those from?" But never mind.
These two vectors, they're both pointing up.
Wait, where'd you get the equal 0 from?
So whenever you're taking summations, it's got to be at equilibrium. That's where we get the 0. So
Mm.
taking all the forces, they have to cancel each other out. That's where you get the 0. Because they cancel each other out, the object or the body is not in motion. It's in equilibrium. We get 0. Does that make
Oh, okay.
sense?
Yeah.
Alright.
I was kind of curious, like, where did we get all the zeros from?
So like there's a force pushing this way, there's a force pushing this way. These have to be equal. They cancel out to 0. This is positive 1, this is negative 1. 1 minus 1 plus negative 1 is equal to 0. So it's not in motion. Beautiful. Let's move on. Those are the only two y vectors we have. So let's just put this RYA is equal to negative 18 kip. This is the same thing we got in problem 3. We have a negative force. So just look at this. Let's simplify this. Let's not make it a hangman thing. Let's just make it a box. All right.
Making them back.
We have an 18 kip here. And we have another force going here. You notice how both of the forces are pointing up? There's no other force pushing it down. So this is going to be pulling with a minus 18 kip. So it's in equilibrium. That's just another way of thinking about it. See how both of these are pointing up? One of them has to quote unquote push down or pull down. So that's going to be this unknown. So it's going to be minus 18 kip. Don't know if that confused anyone. If that confused you, forget about it. This is equal to minus 18 kip. Make sure it's pointing up. And got the first one. Beautiful. Just going to box that. Yeah. Let's make a prettier box. Let's make an even prettier box.
Oh dang!
It's like a label right there.
These boxes getting rounded corners.
Yep.
Trying to turn into apple or what? Trying to rounded box while you rounded box.
All right. We still have two unknowns, RXA and RXB. What's another summation? What's another summation thing we can do? We can do summation of
The moments.
moments. Beautiful. Assuming counterclockwise is going in, is counterclockwise is going to be positive. Where do we take the
Ooh.
moments at? Should we take it at A, B, or C?
I would say C.
B.
What does everyone else
No.
think?
I feel like
I don't know. I feel C because it's going in the opposite direction towards it, but
it's given. C is given, but
Nah, but look, now if it's summation of moments and counterclockwise, one point is
think
going
it-
the other way.
yeah, I think it could be B.
We're actually going to take the summation at C.
Oh, you
Okay.
finessed us.
Why do we do that? It's because we already have a moment at C. right?
Right.
I'm just gonna zoom in and move this over.
Oh, we
have a
already
moment-
have a. Oh, yeah, yeah.
We have a
oh,
moment at C.
Yeah, yeah, yeah.
Let's take this pencil for example. This is gonna be really weird. All right, this is C. There's already a moment. It's pivoting around this point right here. There's a moment. Well, if we take it at a different location, there's a moment going around here, but is it going clockwise? Is it going counter? We don't know. We know for a fact that right here is going to be C. Right here, there's a moment, so we have to take C because we know there's a moment there. This was a bad example. I'm going to do another example. Let's say, come here. Let's say this is going in a clockwise direction, right? How do we get a clockwise direction? We can push it right here, right? It'll go in the clock. Let's say we take the moment over here. It's going in the clockwise direction, right? But we can also push it like this. We can also push it like this. See, it's still going clockwise. But now here, it's going counterclockwise now. You don't know where the force is. You just know there's a moment there. You can't definitely declare or define where the force is a certain distance from this point. If you try to convert this moment at this point into another point, you just can't do that because if the force is going this way, it's going to be clockwise. But if the force is going this way, it's going to be counterclockwise. See, there's this sort of
Oh, so
unknown.
the counterclockwise is going against that.
So the point is,
Wait, so
see,
that counterclockwise is going against that.
so the point is, see, both of these are the same because both of these forces at this moment is the same because it's just going to go clockwise. But if you take these same forces, which remember, they create the same moment at this point. If you take these same exact forces at this point, see how this goes counterclockwise? This one goes clockwise. It's not the same. It's ill-defined in a way. You don't need to know this, but this is just another way of thinking. I think in a lot of different ways. It's just how my brain works. But if that didn't make sense, it doesn't matter. You don't need to know this. It's just some clarification. TLDR, there's already a moment at C, so we have to take the summation of moments at C. That was long-winded. I'm sorry. If one of you understood that, that's great. If none of you understood that, that's fine. Let's just keep moving. Forget what I said if you didn't understand. Summation of moments at C, assuming counterclockwise is positive, equals 0 because it has to be in equilibrium. The body has to be in equilibrium. So we already have a free one, 120 kip feet. Let's go in the negative direction.
So negative 120.
Negative 120 kip times feet. See how this is going clockwise? We're assuming counterclockwise is positive. Since it's going clockwise, it is negative. What's the next force? Oh, there's a force right here. 18. Because we don't know which direction it is. 18 kip. How far away is it from C? How far?
0.
0. Doesn't matter. Because it's pointing directly at where you're taking the summation of moments. It's not going to go anywhere. Bam! It's not going to turn. It's not going to turn. It's not going to turn. This turns, but this doesn't turn. This doesn't turn. Beautiful. So
Wait, so that's 18 times 0?
18 times 0, so that would be 0. 0 kip feet. You don't have to write this out, but it's helpful because you understand what the force has to do with the distance and how that relates to a moment. You don't have to do this. Anyway, RXB, we got a force going right here. RXB, how far away is that from C?
Ooh,
8'4".
no. Well,
Let's extend this vector. How far away is this from C?
it's 5.6.
5.6 feet.
Oh.
Because you're, let's say, just real quick,
Now, do you get it, Santos? Because you saw when he extended the vector, right? You get that.
Yeah. Like I wasn't sure what he meant by how far away was it.
so
from.
let's say this is our body. We're taking the moments right here, right? Push right here. Push right here. It's this much distance away. It's not this much distance away because we can like hypothetically go inside here and push it this way. We can go over here and pull it this way. It's all along the same vector, so perpendicular to that vector is going to be the point. I don't know if that made sense. Another way of thinking about it. If you want me to elaborate more, I can. If you really want to understand, but you don't have to.
Next time.
Next time. All right. Sorry.
No, that's all right.
All right. RXB. That is. Oh God, why is that red? 5.6 feet. Positive or negative?
Negative.
Negative. It's gonna be pushing it clockwise. Negative. See if you extend this vector out. Bam. Does a circle that's going in the negative direction. In the clockwise direction. Cool. You can also think about it as like a particle going circling around a black hole. It's gonna go. You're gonna launch it, and then when it gets close enough, it'll go in a circle in the clockwise direction. All right. RXA. RXA. How far away is it from C?
12.8.
Beautiful. 12.8. Positive or negative?
That's going to be positive.
Positive. Beautiful. See how it's going in the positive direction. Once we pass
Okay.
C, it's going to go around in the positive direction.
Okay, now that I see the swirl like that, I understand it a lot better.
All right. Many different ways of thinking about it. I'm glad one of them stuck.
Yeah. The swirl one, I like that a lot.
Okay,
Like,
okay.
Where like you extend the vector, and I'm like, okay, on point C, what is the vector gonna do? It's gonna curve around like this.
Right.
I like
Yeah.
that. That makes a lot of sense.
Black hole.
That's
It's a
perfect
black
sense
hole
right
and
there.
then-
Black hole, yeah.
Black hole.
That's a really good analogy that helps me understand.
All right,
where-
cool.
Yeah, because the second I saw the 2 arrows on the side and you extended it and went around with that circle right
right.
there, perfect. That clicked in right there.
This makes me happy. This makes me so happy. One of my analogies worked. All right. And then now we have one more, I think. 1, 2, 3, 4, 5. We have one more. RYA. RYA. How far away is that from C?
8'4".
8.4. Yeah.
What does everyone else think?
I think 8.4.
It's 8.4. No one else spoke up.
Oh, okay, Ben. I was about
It's
to say.
8.4. It's 8.4.
Okay, I was just like, is this a trick question? Is it gonna be 0 or?
Yeah. Okay,
Yeah.
and then
So 8.4. And is it going positive or negative direction?
positive.
No, it would be in the
Oh, my bad. Negative.
negative direction.
Negative.
You're going up against it and it's gonna go around.
Yeah, you're right.
Swirly around the black hole.
You're correct. Correct. That is
Man, I visualized that swirl. That's how I knew it was negative.
right. I was about
Yeah.
to draw on my monitor. I was about to take this pen and just draw the.
All right, we're almost there. We're getting closer. We're
Okay.
getting very closer. All right. Just gonna add these 120 and 18. Oh wait, so this 18, that's gonna be 0 because it's multiplying by 0. Doesn't matter.
Not gonna lie, I was being unproductive. Back on track.
Did you get the analogy at least?
Yeah, I get that.
Okay.
Man's
As long as
daydreaming.
you're
I think
learning.
that's what helps a lot because I'm like writing it down as you're saying, like the counter talk was
You're-
fine.
But like, I don't care if you're writing down the homework. If you're learning why we're
Yeah.
doing what we're doing,
Bro, this is so much
That's cool.
helpful than what we've already done.
all right.
Right, yeah. Okay,
Bro,
so
I feel like I'm learning more in this 2
Right.
hours than I have in the entire class.
I know. Clevis fired. Edison hired. Like facts. Just,
And honestly, this time I do not have a headache. Like I swear to God, each time I'm
like
in
this
that
is
class,
fun.
I get a
I'm
headache.
having fun. I'm actually
Yeah.
having fun.
Yeah, I'm
I'm
having a good
having fun.
Facts.
Like I sit with Clevis and like I'm depresso espresso, but I'm here. I'm having fun. Like, fun.
All right.
Like I legit get a headache each time in either one of the classes. I have no idea why.
All right.
So
I think we've all been going for almost 2 hours, but we're almost there. I hope
Right.
you're learning something. Learning is fun
yeah.
when
yeah,
it's not being forced in your face.
right.
That is true. That is very true.
Yes, especially in a relaxed environment.
Yeah. So we
So
got
as long
negative.
as the concepts stick, that's
You're right.
beautiful.
That's what matters. The core concepts, because they're gonna get you more problems anyways.
Yeah. So like, remember how I was doing the triangles and teaching you about the SOHCAHTOA
Right. I needed
instead of
that
just
review.
doing cosine for x, sine for y.
Yeah. Because when he was doing sign, he should have mentioned, like, if y'all don't remember SOHCAHTOA, you know.
Bro, right? Like,
he
come on,
didn't do
man.
that.
We
He
haven't done
didn't do
pre-cal
that.
since like what? It's been for me. It's been like
Exactly. And there's some people who haven't or something. There's some people who haven't done certain things, or like they said they took it, but you know, sometimes.
Like honestly, like if we didn't go over SOHCAHTOA right now,
yeah.
if like fall 2021 is gonna be 2 years since I've done pre-cal. Like since I've had to do math.
Yeah, like I needed
yeah.
that.
I mean,
and
I
the way
always
he
write-
wrote it,
yeah, the way he
the
wrote
way
it.
he
yeah.
wrote it makes some, because I used to write it like, you know, straight out like this.
Yep, that's what I do.
So, yeah, no, but the way he wrote
Yep.
it actually helps you understand what it's supposed to be.
Yeah, I don't think I've ever seen anybody write it.
Write it like
how
that.
Edison
No
wrote
one's
it,
ever
yeah.
written it like that. The way Edison wrote it should be the way it's standardized. Everyone needs to write it like that.
Bro, it blew my mind. I was like, bro, that's
Yeah,
easy.
and
It's top,
that's-
bottom, top, bottom, top,
it,
bottom.
it actually makes sense, because if you write it straight out, you don't know where anything goes. But when you write it like that, yeah.
Yeah.
I feel like maybe once upon a time, a long time ago, in either middle school or high school, I may have seen one of my teachers write it like that, but only for one day. Other than that, it's been
I
straight.
never saw a teacher write. I'm so surprised. Edison, where did you even learn to write it like that?
I think
Bro, dude.
I think I came this up with myself.
no,
up with this
that's
myself.
Crazy. That's
Nah, dude, I'm about to go look
Okay,
up.
so my
Canon
pre-cal
Academy, bro.
my pre-cal
Canon
teacher
Academy, bro.
in
Hold on,
ninth
hold on.
my pre-cal teacher in 9th grade, she didn't really like understand pre-cal. She just like taught it and like
Oh, I don't like those teachers. Or they're just giving us handouts or some shit.
yeah.
They don't even show you anything.
All the teachers.
But like she was super nice. She was like this old white lady. She was super nice. Like she was super caring.
Mhm. This old
But she
hag,
just
yeah,
didn't teach that well. That's
feel
the
you.
problem.
It'd
All right.
be-
Anyway,
I was
But,
even a substitute teacher, bro. Like for like the
Good homework.
whole period.
Okay.
So sad.
Get
all right.
cold.
RXB minus RXB times 5.6 feet. Plus RX times 12.8 feet. And now we know RYA. It's negative 1.8 kips. So just grab our calculator on. There's just 12 point. Don't do 12 point. No. My bad. It's 8.4. Sorry. We're doing this one. RYA times 8.4. 8.4 times RYA, which is negative 1.8 kip. Or is it 18? It's 18. 18 kip. You get 100 minus negative 151.2. So we're gonna minus, see how there's a minus sign, gonna minus negative 151.2. There's two negatives, so we can combine the negatives into a positive.
Oh,
Minus,
you're plugging in RYA, right? That
yeah, you plug
Okay.
plug this in directly into that.
I was just
No,
like, wait a minute, where did we
I
get
thought
the negative 18 from? And then I remembered, like,
no, I
it's in
saw
our
you
back pocket.
rewriting it. I saw you rewriting it. I'm like, wait, why are we writing it twice? I got it though.
You got okay, cool. So we double negative, positive, minus a negative is adding that same number. Plus 152 kip feet. I am running out of space, so I'll just shrunk this real quick.
Strong cuff the zero.
All right. So now let's add these two together. Minus 120 kip feet plus 151.2 kip feet. That would equal 31 point. Sure, I'll notate the point. Decimal point. 31.2 kip feet. All right. Now we have this RXB times a constant plus RXA times a constant. Uh-oh. We have two unknowns again. Can we make that one unknown? We can use this formula. Remember this formula we got? RXA equals negative RXB. Let's just plug that in. Let's substitute RXA, this RXA right here, for a negative RXB. So this is going to stay the same. RXB times negative 5.6 feet plus a negative RXB. So we took this RXA right here and replaced it with negative RXB. This is the equation we solved for earlier. Negative RXB. 12. Why is that negative? That shouldn't be a negative, right? That shouldn't be a negative. This shouldn't be a negative. I don't know why I drew that as a negative. It's just regular 5.6. I think I misread that. Yeah, 5.6. All right, let me just go through this again. 31.2 kip feet minus RXB times 5.6 feet plus negative RXB times 12.8 feet.
No idea why, but I thought it was 3.6 for a while.
3.6.
You're just tripping. Okay.
I'm drawing with the mouse, so
yeah, man, it's no problem. Yeah, I know you're going with the mouse.
the superior
Isn't
drawing
that
tool.
Isn't that RXA? Why'd you put B?
No.
Okay,
He replaced it.
So you see RXA, we're gonna replace it with RXB.
Oh wait, never mind.
RXA equals
No,
negative RXB.
I already wrote it on mine. It's just you wrote it differently. Yep, never mind.
Oh,
Okay. Because see here, we have RXB and RXA. We have two unknowns. We can't get anywhere with two unknowns in one equation. So we're gonna replace one of the unknowns with the same unknown, with the opposite unknown.
This is basically what I did. Like, I just had the equation up there, and I just said, I'm transferring it down over here.
Yeah. So yeah, we're replacing this RXA,
Yeah.
and then we're converting it to negative RXB, and then putting it right there.
All right.
We're just replacing it. So we have one unknown. Yeah, we have RXB and RXB. So we have 31.2 kip feet. Kip feet minus RXB times 5.6 feet minus RXB times 12.8 feet. So why I did here, I just made this plus negative into a minus. So we can actually just simplify that. So it's just a minus 18 RXB times 18.4 feet. Does that make sense? Does
Yeah.
everyone know why we added these together?
You're just simplifying it because they're both the same variable.
Yes, they both have the same unknown, RXB, and they both have consonants, 5.6 and 12.8. We can add those together. Simple algebra. We have a 2x and a 3x. We can make it a 5x. Now replace the x with RXB. 2RXB plus 3RXB equals, this is just an example, you don't have to write this down, 5RXB. Now replace the 2's and 3's with 5.6 feet times RXB plus 12.8 feet times RXB. Yeah, RXB equals 18 RXB. So it's just simple algebra why we added this together. The only reason I'm saying this is because I overthink it. So I'm just clarifying it for you guys if you guys are overthinking it, which you probably are not. I'm just paranoid. All right. We got this. Let's move RXB to the other side. RXB. It was negative. Now it's positive because we added it to both sides. RXB times 18.4 feet equals 31.2 kip feet. Divide both sides by 18.4. RXB is equal to doing math. Divided by 18.4 is equal to 1.696 kips. We divide by feet. The feet cancel out. We're just left with kips. RXB is equal to 1.696 kips. Box
Nice.
that. And that's the problem. Wait. That is not the problem. Or is that the problem?
How is that not the problem? That is the problem. It said
Hold
in the
on.
structure below, horizontal and vertical reaction at point A. So isn't that just RXA and RAY?
Wait,
Bro,
okay.
we solve for
Hold on.
RXB. Bro.
We have to solve for RXA. We solve for RXB. We have to solve for RXA. See, this is red. I was looking at my notes. I'm like, wait, no, this is not right.
Wait. What are you saying?
So you see here, we're solving for RXA
Also,
and
RXA equals the
RYA.
negative RXB. Oh, yeah.
So yeah, we just take this
Ooh.
back into this. RXA is equal to negative RXB. Just take that, plug it into there. RXA is equal to negative 1.696 kip.
No, wait. Wouldn't it stay positive because that's because it's
Look
not negative RXB?
Look at this equation. RXA equals negative RXB, right?
Mhm.
RXA equals negative RXB. RXB is positive 1.696 kips. Plug in 1.696 kips into RXB, you get 1.696 kips. You still
okay.
have the negative, so it becomes negative 1.696 kips.
So RXA equals negative 1.696 kips.
Yeah.
There we go.
But then
So-
RAY equals negative 18 kip.
Negative 18 kip.
And that's your two answers. for
That's your
number
two answers. Negative 1.696 kip. And this
So-
is
So now
0.6.
that was it for number 4. That was our RAY is negative 18 kip. RAX is negative 1.696.
Yep.
Okay. Cool. Cool.
So,
Cool. Cool.
Just to reiterate,
Cool.
RYA, this is what we are looking for, equals negative 18 kip. And then RXA, this is also what we are looking for, is negative 1.696 kip. Now you can't just write this, you have to notate which way the vectors are facing. So make sure you scan your free body diagram or redraw it on your answer sheet, on your worksheet.
I just
Okay.
redrew it.
So it's just the red arrows, right?
Those are the red arrows.
I got you. Okay. Now, so let me real quick. So for number 3, the previous question, the final answer was negative 0.16 kip for RYD, right? For number 3.
Maybe, were you paying attention?
Yeah, yeah.
All right. If you think that's the correct answer, it's the correct answer.
Okay, I think they're all correct.
All right.
I don't need to review them.
All right. I'm going to stop the recording and cool.
All right, hang on. So number 2, the correct answer was
Stop this.
was
Hold on. I need to